In this video, we will study three diagrams without replacement for three color balls with sampling of 2. An urn contains 9 blue, 5 red, and 3 green balls. 2 balls are picked up at random without returning the balls to the urn. First question, what is the number of all possible outcomes or the number of elements in the sample space? First thing we do, we number the balls. So we number the blue balls from 1 to 9, the red balls from 1 to 5, the green balls from 1 to 3, or we number all of them from 1 to 17. So let us first examine the drawing process. We may pick 11 blue and after that 6 red, or 6 red and after that 11 blue. So the balls come out of the urn in order. And the actual sample space is composed of ordered elements. So the outcome of the probability experiment is ordered and without replacement. So the number of elements in the sample space for the case of order can be computed from the permutation formula under the condition of withdrawing without replacement. So we have N, the number of population is 17, and R is the sampling size. We are sampling 2 balls only, so R is 2, and we use the permutation formula without replacement. We substitute N for 17 and R for 2, and we get 17 times 16, and that is 272 elements in the sample space. Question number 2, find the probability of the joint outcome event using the tree diagram. So let B represent drawing a blue ball, R represents drawing red ball, and G represent drawing green ball. So we are starting with 9 blue, 5 red, and 3 G. And the total number of balls is 17. In the first draw, we may pick blue, red, or green, and the total number of balls after the first draw is 16 balls. For the second draw, we may again pick blue, red, or green, and now we can have all possible joint outcome for the first draw and the second draw. These are all the joint outcome. We may pick red first and blue second. We may pick green first and green second, and so on. So let us find the remaining balls after the first draw. So if we pick 1 blue here, then the remaining blue is 9 minus 1, and that is 8 blue. And the remaining red will be 5 minus 0, and that is 5. The remaining green is 3 minus 0, and that is 3. Now if we pick 1 red, then the remaining red is 5 minus 1, and that is 4. And the remaining blue will be 9, and the remaining green will be 3. If we pick 1 green, then the remaining green is 3 minus 1, and that is 2. And the remaining number of blue and red will be the same, 9 and 5. Now let us find the probability for each joint outcome. In the first draw, we are picking 1 ball out of 17, so the probability denominator is 17. Now in the second draw, we are picking 1 ball out of 16, so the probability denominator is 16. So what is the probability of picking the first blue? So we have 9 blue, so the number of favorable outcome is 9, and the probability is 9 over 17. And what is the probability of picking the first red? We have 5 red here, favorable outcome, so it is 5 over 17. And what is the probability of picking the first green? So we have 3 green here, so it is 3 over 17. So now what is the probability of picking blue after the first blue? We have 8 blue available, favorable outcome, so it is 8 over 16. And what is the probability of picking red after the first blue? We have 5 red available, so it is 5 over 16. And what is the probability of picking green after the first blue? We have 3 green available, favorable outcome, so it is 3 over 16. And what is the probability of picking red after the first red? So we have 4 red favorable outcome available to us, so it is 4 over 16. So we keep doing that for the events in the second draw to get their probabilities, as we see here, 9 over 16, 5 over 16, until we finish. And now let us find the probability for each joint outcome. So let us find the probability of first blue and second blue. So we highlight the branches leading to this event, and we multiply the probability of the first branch with the probability of the second branch, and we get the probability of blue first and blue second. So let us find the probability of blue first and red second. We highlight the branches of the tree leading to this event, and we multiply the probability of the first branch with the probability of the second branch, and we get the probability of first blue and second red. So let us find also the probability of first blue and second green. We highlight the branches leading to this event, and we multiply the probability of picking blue with the probability of picking green, and we get the probability of first blue and second green. So let us also find the probability of first red and second blue. We highlight the branches leading to this event, and we multiply the probability of picking first red with the probability of picking second blue, and we get the probability of red first and second blue. And we keep doing that for each joint outcome to find its probability. As we see, we highlight the path, we multiply the probabilities, and we keep doing that, highlight and multiply. We keep doing that until we finish from all the joint probability events. Now let us isolate all the possible joint outcome, turn them around, and put them in the sample space. The sample space has 272 possible outcomes. We will name each event, so such as this event, first green and second blue, and this event create partition in the sample space. After that, we compute the numerator and denominator for each probability, as we see, and we add the probability of these events to make sure that they are equal to 1, and they are. Question number 3. What is the probability of picking at least one green? So back to the sample space, we may pick one green or we may pick 2 greens. So the probability of this event is the sum of probabilities of these individual highlighted events, because these events are disjoint. So we add their probabilities, and we get 90 over 272, and this is equal 0.33. Question number 4. What is the probability of picking one blue and one green? So back to the sample space, We may pick first blue and second green, or first green and second blue. So the probability of picking one blue and one green is equal to the sum of probabilities of these two disjoint events. So we add them together and we get 0.19. Thank you for watching and have a good day.